Please, while watching this
Hello
video,
and
make sure you watch
welcome once
alongside with
more
a
to
piece of
another
paper and a
video on
pen,
my YouTube channel.
so that
I
whatever
am
activity
Tem
I'm doing here, you
Achemteze
will do
presenting
actually
this
the same
script.
thing. Because just
Our
watching
target
the video
today
without
is
writing
on
anything, you end
further
up
math
learning nothing.
students equation on
Psychologists
reduction
have proven
formulas
that.
GC
So, make
2006.
sure you have
The
a piece
question
of paper
reads,
by your side.
given
And
that for
please,
all
don't forget
n
to hit the
for n
subscribe
greater than
button,
or
the
equals
red
to
button.
0,
That is
where
all.
n is an element in the set of real numbers,
That will encourage me and
In
create
is
more
defined to
wonderful
be
content for you
this
guys.
integral
Enjoy
in
your
terms of
video.
n as a function of n, x to the power n sine x dx. So you should prove that for n greater than or equals to 2, in is equals to pi n minus n into n minus 1 in minus 2. Hence, evaluate I4. Basically, this is a question that requires you to use the notion of integration by parts to prove it. Now, to do this proof of this reduction formula, we are going to use integration by parts. So I'll begin by writing down the solution here. So I'll begin by writing down the solution here. To do this, I'm going to use the formula for integration by part, which says that the integral of what? U dv is equals to what? U times v minus the integral of what? V du. So that's the formula for integration by part. In using this formula, we have to choose u to be a function which becomes simpler when differentiated, and our function v dv should be a function which can easily be integrated to get v. Now, following that property here, the purpose of using integration by part is to reduce the power of n, so that the integral becomes more easy to simplify. For instance, now if I want to integrate this, I'm going to let u should be the function that carries a n, because when I differentiate that, the power will drop. Yeah. So I'll let my u to be this, which implies du by dx. If I differentiate u with respect to x, will be equals to what? How do we differentiate this type of function? We just drop the power and reduce the power of the function by 1. That is exactly what we get. So from here, we need du, right? So if I make du the subject, my du will be equals to what? N x to the power n minus 1 dx. That is basically du. Then the other part of the function, which is dv, once you make your choice for u, the other part of the function represents dv, which is sine x dx. So this is equal to sine x dx. Remember, to get v, we integrate, right? So integrating the sine function gives us the negative of what? The cosine function, because this is dv equals to this. So I'm going to integrate both sides to solve for v. When this is just a derivative of v, when I integrate it, it goes back to what? The primitive of v equals to what? When I integrate the sine function, I'm going to get negative cosine of x. Yeah, negative cosine of x. Once we have this, now we apply that into our formula. Our integral of what? U dv. U is what? This function in. This one here represents the original integral. Our original integral is this, right? And it has been represented by in. So this integral here is in equals to what? U is what? Xn. And v is a negative cosine x, negative cosine x. And we were told that the limits were from 0 to what? The limit of integration was from 0 to pi. So I'm going to integrate, I'm going to substitute the limit here at once. Minus this one, integral from what? 0 to pi of what? V is what? Negative cosine x times what? Du is what? N x to the power n minus 1 ma dx. Let's simplify this. When you replace pi here, right? Let's simplify a bit. When you replace the upper limit here, you are going to have what? Pi raised to the power n, right? Then now when you replace pi here, cos pi is -1, negative times negative give +1 times pi raised to the power n. I'm going to have pi raised to the power n. Now when you put 0 here for x, everything will be automatically be 0, right? So from here now, negative times negative will give positive, and then the n comes outside, plus n integral from 0 to pi of what? X raised to the power n minus 1 cosine x dx. The next step is to recognize that this one, to get in minus 2, it means that the power on x must be what? Negative uh negative 2, n. The power on this x should be n minus 2. If I differentiate this one again, I'm going to have n minus 2 on the power, right? So I'm going to apply the notion of integration by part to this function again. So I'll call this one, let I be the integral from 0 to pi of x to the power n minus 1 cosine x dx. So I'm going to let my u be this function, which implies differentiating both sides and have du to be equal to what? N minus 1 x to the power n minus 2. We copy the power and reduce the power by 1. So it becomes n minus 1 minus 1, which is n minus 2 dx. Then now I'm going to have du dv to be equal to what? The other part of the function. I'm applying the integration by part formula again. After doing that, we integrate both sides. Basically, integrating both sides, I'm going to get v to be equal to what? So I get v to be equal to, where integrate cosine function, you have the sine function. Yeah. Now it means that this is the integral I, according to the formula of integration by part, I is the original integral. This is this one, uv. This is v and this is u. So it becomes x to the power n minus 1 sine x. The limits of integration have been given to 0, from 0 to pi. Then minus integral of v du. V is what? Sine x. Du is n minus 1 x to the power n minus 2 dx. Now when you put sine pi is 0, cos pi, when you put 0 here, everything will be 0. So this term turns out to be 0. So we will not write it down. Now this one here, we can remove, factor out this n minus 1. So you have negative n minus 1 like that. Integral from 0 to pi of what? X to the power n minus 2 sine x dx. Now if you recognize this, you see that this is just the integral when n is equal to n minus 2. So this is equal to what? N negative into n minus 1 times n in minus 2. Yeah, this is just the integral when n is replaced by n minus 1. So this is actually in minus 2. This is I. I'll come and replace. Remember, I represent this integral here. So I'll replace it there. So it means that my in will now become pi raised to the power n plus n into what? My this one, which is this, right? Negative n minus 1 in minus 2. So this one will be equal to pi raised to the power n minus n into n minus 1 in minus 2. This is in. And this is the integral. This is the proof to this reduction formula. Remember, our integral was true when n starts from 0. So we can only have I0, cannot have negative values. That's why here the only value that was make this integral to start from 0 is n equals to 2. So that's why we say n is greater than or equals to 2. So that's the first part of the answer. Okay, now let's say the next part of the question says hence evaluate I4. Hence evaluate I4. How do you get I4? We are going to use this our reduction formula here, the one we just proved. So even if you are solving right and you fail to prove this formula, you can still answer this part and pass it. So we had in to be equal to pi raised to the power n minus n into n minus 1 in minus 2, and we told that n is greater than or equals to 2. So I4 is actually equals to what? Means that anywhere I see n, I replace it by 4. So I'm going to get something like pi raised to the power 4 minus 4 into what? Where I put 4 here minus 1 gives 3. In, where I put 4 here, it becomes I2. So the next step is to get I2. So let me just simplify. So I have pi to the power 4 minus 12 I2. Then now I2, to get I2, I come back to this same reduction formula here. So I'm going to replace n by 2. I2 become pi raised to the power 2 minus 2 into what? 2 minus 1, which gives 1. In minus, that's I, you put 2 here, it becomes 2 minus 2, that gives I0. Remember, our integral, original integral was true for n greater than or equals to 0. So to get I0, I'll go back to what? The original integral. So I0, this is actually pi raised to the power 2 minus 2I0. So I'm going to get I0, which is equals to what? The integral. Because it says it's true for n greater than or equals to 0. So I can also use this formula to get I0. So in that case, to get I0, I'll simply replace n by what? By 0 in the original integral. So it becomes x raised to the power 0, which will give 1 times sine x. So it will just be the integral from 0 to pi of sine x dx. When you integrate the sine function, you have negative cosine x. Then you put a limit of integration from 0 to pi. That should give you negative, where you put negative cos pi minus cos 0. Now, minus negative cos 0, that's upper limit minus lower limit. Now, when you replace, cos pi is negative 1, so this one turns out to be positive 1. Then cos 0 is what? Cos 0 is 1. So I have negative 1 times this gives 1. So this turned out to be 2. Now, we come back here. This is the value for I0. So it means that I2 will become what? Pi squared minus 2 into 2, which gives me what? Pi squared minus 4. This is I2. And I4 was in terms of what? I2. So it means that finally I4 will be equals to what? Pi raised to the power 4 minus 12 into I2. I2 is what? Pi squared minus 4. So this is actually pi raised to the power 4 minus what? 12 pi squared plus 48. Yeah, 48. So you see that this is actually what? A conceived quadratic. Yeah, it's a polynomial in terms of pi. So that's the value for I4. So I hope this video was helpful, and please kindly drop some of your requests in the comment section. Please, if you are new to my channel, kindly subscribe, hit the subscribe button, the red button, so that it will encourage me to create more wonderful content for you guys. See you guys in my next tutorial, and stay amazingly blessed. Bye.